For this lesson, we're going to go over our exponent rules. The first little bit of this will be review from grade 8 and grade 9, but the second part will be new for grade 10. Just a quick little bit of vocabulary here to begin with. The whole thing, the part that we have circled here, when you have the thing with the thing in the air, which we'll put words to in a minute, that is called a power. So the whole thing is a power. The thing up in the air you should know as the exponent, and the part that is on the bottom is known as the base. So the base of something is the bottom of something. So this power has a base of x and an exponent of n. First rule we're going to look at is multiplying powers with the same base. So for example, if you've got 5 squared times 5 to the 4, in expanded form, the 5 squared, so the 5 squared here, really is 5 times 5 times 5. And then the 5 to the 4 really is the same thing as 5 times 5 times 5 times 5, or 4 factors of 5. All together here, we now have 1, 2, 3, 4, 5, 6 factors of 5. Remember, factors are things that just get multiplied together. So 5 is multiplying itself 6 times. So as a single power, that is 5 to the exponent of 6. Now there is a rule that we can work with these numbers, the exponents, to get 5 to the exponent of 6 out of that. All right, so you're going to write the expanded form for the next part. That would be negative 2 times negative 2 times negative 2 times negative 2, 4 times of negative 2. And then we're going to have another 2 times of negative 2. So altogether here we have 6 factors of negative 2, or negative 2 to the exponent of 6. All right, for our last example here, we've got x to the exponent of 2. That means we have 2 factors of x, and then we're multiplying another 3 factors of x. So we're going to have x. I'm just going to use a dot for multiplication here, because if I put the time signs in, it's going to be looking kind of crazy. So we've got our 2 factors of x here, multiplying 3 more factors of x. Altogether we have 5 factors of x, or x to the exponent of 5. Okay, so the quick rule then, if you look at this, you're going to keep the base the same. The base did not change. What I had for the first example was 5 as my base, and the 5 stays the base of 5. We're just adding those exponent values together. So 2 plus 4 gave us a new exponent of 6 here. Or 4 plus 2 gave us an exponent of 6 here. Or 2 plus 3 gave us an exponent of 5 here. But the base stays the same. So we're keeping the base as it is, but we add the exponents together to get the new exponent. And now we're going to look at what happens when we divide powers with the same base. So for my example here, I have 5 to the 5 divided by 5 cubed. So on the top, we have 5 factors of 5. This 5 to the 5 really could, divided by 5 to the 3, could be written as 5 to the 5 divided by, so the divide line can be written as a fraction line, divided by 5 to the exponent 3. So we've got 5 factors of 5 on the top and 3 factors of 5 on the bottom. Now if I have a 5 dividing by a 5, if I multiply the top by 5 and multiply the bottom by 5, I could just put that in a reduced form by canceling those out. And similarly, this multiply by 5 on the top would reduce with a multiply by 5 on the bottom. And I have another pair of 5s that could also reduce. So what I'm left with here are just 2 factors of 5, or 5 to the exponent of 2. If I do that with the next ones, you're going to find a pattern that happens with those as well. So when we look at this, we end up with 1 factor of negative 7, or negative 7 to the 1, which is the same thing as just negative 7. When no exponent is written, it's assumed to be a 1. So we should be noticing a pattern. Our base, again, is staying the same. It's just the exponent that's changing. So if you look at the exponents that were originally given, what can we do with those two numbers to get the new exponent? And we'll do that with this last example. We've got 6 factors of x on the top, and then we've got 2 factors of x on the bottom. So we write our 6 factors of x on the top and our 2 factors of x on the bottom, and then we match them up to reduce them. So x reduces with x reduces with another x. It leaves us with 4 factors of x on the top. And then that would be x to the exponent of 4. Click, click goes my pencil. All right, now the rule here will be similar to the rule for multiplying. It's just instead of adding the exponents to get the new exponent, we're going to subtract the exponents to get the new exponent. Okay, now the third one that we should also know from our previous years is the power of a power. So power of a power, on the first example, I've got 5 squared all to the exponent of 3. So I've got my original power in here, 5 squared, but now I have another exponent on it. That really means I've got 3 factors of 5 squared, or 5 times 5, there's a 5 squared, times another 5 times 5, or 5 squared, times another 5 times 5. So altogether, I have 6 5s being multiplied together, or 6 factors of 5. That gives us 5 to the 6. And we can do the same type of thing with our next example. We've got 4 factors of 3 squared, or 4 factors of 3 times 3. So altogether, oops, I missed a 3. Altogether, we have 8 3's being multiplied. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 factors of 3, or 3 to the exponent of 8. 3 to the exponent of 8. So again, the base stayed the same. The bottom number stays the same. It's something that we're doing with the exponents to get our new exponent here. We've got an x cubed to the exponent of 3, so we've got 3 factors of x cubed. We're going to find a rule for that. Okay, and hopefully you remember that rule actually is the base stays the same, stays as it is, and we're just multiplying those powers, those exponents together. So keep the base as it is and multiply the exponents to the new exponent. So hopefully you remember those rules from previous years. But now we're going to look at a new rule. You may have touched on that last year, but you may not have. Okay, so the zero exponent rule, we're going to look at an example here of a to the 5 divided by a to the 5. On the previous part, we were talking about dividing when the bases are the same. When we're dividing and the bases are the same, the rule is we keep the base as it is, so the base is still going to be a, and then we're going to subtract our exponents. So we're going to have 5 take away 5. 5 take away 5 is the same thing as 0. So we have a 0 exponent here. Now, I want to write this the other way. This really is a to the 5 divided by a to the 5 would really be a to the 5 divided by a to the 5. You can think of that as 5 factors of a on the top, and I'm just going to use dots for the multiply instead of the times symbols. So we've got 5 factors of a on the top, and we have 5 factors of a on the bottom. And in fact, I could make this even simpler by talking about it in another way, but I'm going to reduce this like we did with our dividing ones on the other side. 1 factor of a divides another factor of a, it reduces. So I'm just reducing each one of these, and every time I reduce, I'm going to be left with a 1. So if I have like a cancels with a, or a divided by a divided by a is a 1. A divided by the second pair of a is equal to 1. A divided by a on this pair is a 1. So altogether, I'm going to have 5 1s multiplying each other. So 1 times 1 times 1 times 1 times 1 is just going to equal 1. Now, you could also think of this in another way, if this is confusing for you. If you have a number on the top and you're dividing it by itself, we know from years and years ago when we first learned about dividing, anything divided by itself is always equal to 1. So just another way of looking at that rule. So in the end, we started with the very same question in both cases. We started with a to the 5 divided by a to the 5 and a to the 5 divided by a to the 5. In one case, we got it to be a to the 0. In the other case, we got it equaling 1. So we can draw the conclusion then that a to the 0 has to equal 1. And in fact, that's true. If you try any number on your calculator that you would like and put it to the exponent of 0 using your exponent button, it's going to pop out an answer of 1. All right, so that's an important case to know. Now, just remember, brackets make a difference on this. So, for example, if you have 5 to the exponent 0, that's going to equal 1. If you have negative 5 in brackets. That whole -5 is the base because everything in the bracket gets that exponent of 0. That would equal +1. But if you do -5 without brackets to the exponent of 0, that's actually going to equal negative, and then 5 to the 0 is the 1. So brackets make a difference. Make sure you understand that with the brackets, the negative's included as part of the base. Without the brackets, only the 5 is the base. So make sure you know what the base is for that particular power. All right, the next thing we're going to look at is the negative exponent rule. We're going to consider an example of a to the 3 divided by a to the 5. If we use the quotient rule, the rule of what we do when we're dividing, we keep our base the same and we're going to subtract those exponents. So we're going to have 3 take away 5, and that's going to give us a to the exponent -2. If I do what we did up above and rewrite this as a to the 3 divided by a to the 5, we're going to end up with 3 factors of a on the top and 5 factors of a on the bottom. And then we're going to pair things up again and reduce. And when we reduce, we get 1s. So I've got my 5 factors of a on the bottom. I can reduce the first pair. A divided by a is a 1. The second pair of a's, a divided by a would be 1. The third pair of a's, a divided by a is 1. And then I've run out of a's to reduce with. So on the top, I'm left with 1 times 1 times 1, which is 1. And on the bottom, I still have a times a, or a squared. So again, we started with the same question here and here, and we did slightly different things, but they were both valid things to do. And we ended up here and here, so we can conclude that a to the exponent -2 is the same thing as 1 over a to the exponent +2. So by that negative exponent, it means slide that base to the bottom of a fraction and change the exponent to be positive. Now, we've got a couple more examples here, and timing-wise, I think we've got a couple more minutes before I have to stop the video. All right, consider this. So if I've got a to the -2 on the bottom, that's the same thing as, instead of writing that divide line like the fraction line, I'm going to write it like this. 1 divided by a to the -2. Okay, so this fraction line is the same thing as the divide symbol. Now, from up above, I know that a to the -2 is the same thing as 1 over a squared. So that's going to be 1 divided by 1 over a squared. Now, there's a rule when you're dividing by fractions, you change that into multiply by the reciprocal. I'm going to flip that over, and that's going to become a squared over 1. So 1 over 1 times a squared over 1 is just a squared. So my conclusion here is that 1 over a to the -2 is the same thing as a to the +2. All right, let's consider this one over here. We have an a to the -2. That's going to be the same as a to the -2 divided by b to the -2. Sorry, I think I said that incorrectly when I said I have a over b to the -2 there. So let's rewrite it as a to the -2 divided by b to the -2. From my first example up underneath the negative exponent rule, that a to the -2 is 1 over a squared. I'm going to divide by, if I apply that rule but just with the letter b, that would be 1 over b squared. And then I'm going to apply the rule that I'm going to multiply by the reciprocal, so times by b squared over 1. The rule when you're multiplying fractions together is you multiply your numerators together, multiply your denominators together. So we end up with a over b to the -2 being the same thing as b over a all to the +2, because really that +2 would affect both the b to make and the a to make it a b squared over a squared. So that's our negative exponent rule, which we'll summarize. So when working with a negative exponent, just switch the base's position. If it's a negative exponent and the base is on the bottom of a fraction, switch it from the bottom up to the top. If the exponent is negative on that base and it's on the top of a fraction, move it down to the bottom of the fraction.